Okay, terrific. And hi everyone. Today's stream, we are going to answer this question, basically. And before I get going, I'm just going to go and find AI, try to make sure we have the stream ready to go. Here we go. Double check the stream. Okay, terrific. And hi everyone. Today's going to go put some music on because it's a little bit of a lot of work to do this, and we don't want to get too burned out. And we're going to post it. Okay, so turn off the stream. We have a notebook set up. This is our environment for manipulating and viewing and playing around with data. Let's turn the music down a little bit so I can think. And let's look at some documents that kind of teach us how to do this. Don't trust Campbell's word for it. So we have a file set up here. We're going to look at Excel too. We've done some data cleaning, but let's just imagine you're from a totally blank slate. We're going to go here and look at that set of, just go to Google, forward volatility. With typos, let's look for Wikipedia. Okay, we're going to read this formula. So what is it saying? Forward vol is the measure of implied volatility over a period in the future, extracted from the term structure, aka the shape of volatility. Okay, what you need to know to be able to do this is all you need to know, although it can be a little bit confusing, is that variance adds arithmetically. Standard deviation does not. The variance is the standard deviation squared. So you do this math. This is Taleb, not me. And it gives you this handy dandy formula, which we're going to use here. So let's actually look at this formula right now. And what does this formula say? And I'm going to move this over here so I can edit it. While we go. And this is saying, for example, that if you wanted to calculate the forward variance and you had 90 days of variance and 180 days, and the 90 days was 18% annualized, and the 180 was 16% over the whole period, what would the gap between 90 days and 180 days volatility, in this case, need to be to make the average 16.66%? So, okay, let's do that in math. So we pull up our Excel file or a notepad, right? And we're going to say period. Start with Excel just so you know the math works. Then you can put it into code, right? And we're going to go all P1, P2, I'm not sure, 90, 90. Okay, now what's our volatility? This is the time. Volatility for 180 days is 16.6. So there we go. Volatility for 90 of those days is 18. And this formula is saying take the weight of the period of time, in this case 90 divided by 180, right? So weight equals 90, or 180 minus this, right? Equals 180 minus this. That's my 90. This is now a formula. And now I can say weight. It's going to be equals this divided by this. Super easy, 50-50 at the beginning. This is going to be equals 1 minus this. Okay? And now this formula needs to say equals difference in the full volatility minus the period volatility divided by the amount of weight that's left in your thing, square root. So let's start with the square root, right? And just say square root of 16 just to start, make sure we know the formula works. Now we're going to divide it by 0.25. And just make sure we can recreate this number. 0.5 times 16.66 to the blah, blah, blah. So we're going to need 0.5 times 0.66 squared minus 0.5 times 0.18, in this case squared, and I made a mistake in my algebra here. This should be a multiplication, I think, right? Yeah. Okay, so 0.5 times this to the power, maybe we need to do pow, right? So pow, Excel, equals pow 2, 10 to the 2. That should work. So let's just do it even more simple here. We're going to say this is the standard deviation, this is the variance, equals this. Okay, and that formula is saying square root of the weight, let's move these down, here, equals square root, let's just multiply the weight times this, right, minus 0.5 times that, oh wait, that's why, 0.5 and 0.25, that was my mistake. There we go, 15.07. Okay, so we know we can do the math, that's why we do it just in Excel to make sure we can actually make the math work. Now we recreate the math, and this is actually weight 5. Aha! Why is it weight 5? 1.25. Good question, because it's not divided by 180, it's actually divided by how much of the year it is, because we're in annualized vol space. So let's say 360 to make it easy on the people who did this formula. Aha. So now when we do that, it's going to error out because it doesn't know what standard deviation is. This will help us check it later. So this is saying take the standard deviation, multiply it by the weight, whoop, right? Take the difference of these two things, divide it by 0.25, and take the square root. So square root of this minus this, 2, take this, divide by 0.25, also known as the weight. Whoops. 0.5 times this minus 0.5 times that. There we go, that. Right, there we go, that. What did I do wrong? Make it simpler for yourself. Got to get this math right, unfortunately. That's the variance that's left. Divide by 0.25. Square root of that. Uh-oh. Ample. What did I do wrong there? So square root of squared divided by 0.25 equals 15. So we got that part right. So why is this part not working? This is where it goes slow. That's okay. Aha, because I did additive. Because I don't have the right thing. There we go. That makes sense. And there we have our number. Yay. Okay. Whew. So this scales to arbitrary lengths. So if we had, let's imagine that this is saying 6-month vol, what we generally call it 6-month vol, right, is made up of 1 3-month period and 1 3-month period. And this would be T0 to T whatever 90 days, and this is going to be T 90 days out to 180 days, right? So if we generalize this and say we're actually going to look at, I don't know, 270 days, so 9-month options, right? 9 months. And we wanted to look at 6-month options. There we go. Fix this formula here. F, right? So we're going to lock this cell. And this is all going to be for the same thing. Right? It's saying 75% of the year, 50% of the year, 25% of the year. If we have the same standard deviation, 16, 18, our variance is going to be different. Not our variance is different, but our like weighted variance. I don't know that's a technical term, but see how it's different than that 0.13 because it's more of the year, right? And so similarly, this is to make these like kind of comparable numbers. That this formula, the difference, the square root, let's put that in one formula. Now that we know that it's right, square root, this is from Lehman, they taught us this stuff, which is so fun, divided by my weight, Bob's your uncle, 15.07. Okay, so now, what this is saying, is that if you imagine like a number line where you have 90 days, 90 days, 90 days, 90 days, that in the old model, you had 15 point, or let's start with the first one, 18 vol for period 1, quarter 1, quarter 1, quarter 2, quarter 3, quarter 4, right? 18 vol, 15.07%. That forward vol, which in this case is the vol between Q1 and Q2, is 15.07. And the total period vol is going to be the inverse of that number, which is going to give us the 16. Meaning, let's just do it on the fly. If we were to do the square root of 0.25 equals 0.25 times 18 vol plus 0.25 times 15 vol, right? Equals this times 50, 0.5. Or divide by 0.5 equals square root 40. That's not right. It's additive. I'm probably going too fast here. Gotta get this right. So 0.25 times this plus 0.25 times that should be equal to 0.5 times, where's our number here? 18 squared. Okay, 1.06 number. Right. Oh, math is fun. Okay. So it's saying the variance over the whole period minus the variance of part of the period divided by the remaining weight equals this thing. Okay, well, let's actually do it for real. So let's look at the S&P, and then we can try to do like treasuries or something. 3 month, 6 month, 6 month, 9 month, 12 month, 24 month. And this is going to be actual data. So we're going to go here. And even though this is going to be 100% moneyness, now we're going to look at rows a little bit for the first time. And first thing we're going to do is do some documentation, because we're now going to get an answer. And we're going to go up here, take this Wikipedia, put it in here for some answers. We can do images later, and we're going to try to pull the data that's in this thing here. Hopefully it exists. Let's see what we get. So this is actually the VIX. I don't want to do, is the question term structure of vol or term structure of VIX? Oh, what the 1 month forward of VIX futures is. Well, let's make sure that those are the right futures first of all. So let's go into rows here. So this is the vol of the vol. In a sense, it's not actually the VIX, it's the price of VIX options. We go to VIX here, and the VIX is like an abstraction. There's just a bunch of VIXs, right? Spot is trading at 16. What does that mean? Curve, finder. commodity curve analysis, and then it transmutes into this thing. And the issue is that these are actually forward vols. So what that means is that UXJ3, let's put that in a spreadsheet, UXJ3 commodity and UXK3, there's some arcane UXK3 commodity. Now we have M. And probably extract these, but I just want to like actually have them for real. N. Q. U3, X3, probably C3 at the end, but great. Yeah. C's in deck. And you can also find this in rows here by typing in PVG month. Right, and they give it some sort of silly thing here. And I'm just looking for the codes here, literally. So you can see that this J starts in April and goes out to December. Great. So these are the actual, I'll call this USA Equity Vol VIX, 1 month, future price. Great. And this is going to be equal to April and 23 dot raw dot ppg. And we're going to push all these. Okay, and make a little code here. And what I'm doing is I'm cleaning the data, I'm modeling it, is what we call it, so that now I can find it. Because I don't want to know, push Bloomberg, I don't want to remember UXJ3. I don't want to remember UXK3. I gotta do math. Why would I want to do math while I'm doing that? So while I'm doing that, I gotta go. What we're going to do is we're going to use these individual curves. This is the forward curve to arrive at what we think volatility will be over that period. And we can compare it to like 6-month equity volatility in the U.S. stock market. And they'll be a little different, but they should be close enough. So take all these, put it in rows. Okay, this is a lot of like moving around stuff, but this is just organizing information. Make sure we have it all in one code. Oh, great, look at this terrible data. Because they were only recently pulled. So now we're gonna think, maybe we want not the actual, what we call sticky maturity, but we actually want next month and the month after that, the month after that. So let's look for that in Bloomberg too. It's called the triangulation. So we know the futures code is UX. So look for UX1. There it is, right? And so here, we're gonna go and find the whole curve for all these different things. And this is an abstraction because UX1 does not actually exist, but I'm gonna make it here and I'll call it UX and this and space commodity. Okay, that's what they call all these different, they call them indexes. Good catch. Call this USA, same code basically, right? But instead of it being a specific date, it's a fixed maturity, meaning 1 month, 2 months, 3 months. Heaven forbid. Okay. So USA equity volatility, VIX, 1 month future price, and it's going to be equals this months, or just month, dot, not 23, raw. Don't forget your corrections. Go down here, go down here. Great. Equals push G. And this should give us an equivalent to not this data, but that curve we saw earlier, this thing. Where now this visualization is showing you the specific future that is the 1 month, 2 month, 3 month, 4 month. But let's actually do the whole curve, and hopefully if the data is not too misaligned, it won't be that bad. And we can go from here and say, okay, given this set of data is the 1 month forward expected vol, the 2 month forward expected vol, the 3 month forward expected vol, what is 12 month volatility expectations? And let's just look for that in rows. So we're going to call USA vol 12 month. Vol 12M. Let's look for implied. Here we go. Nope, that's an actual stock. SPY maybe, SPX wall, let's look for 12 months. Let's look for 1 year. Oh, I see it down here somewhere. Here's 24. There's 6 nearby, 1 month, the ones I just made. Let's look for 100. Really? That just seems odd. Well, I guess we can make that too. So let's go here, and we're going to look. First of all, let's update this. Now that it doesn't have all those codes, it only has the first 6 months. So this is going to go here and say probably SPX index, 24 month implied vol, blah 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 blah. So if we go here, I really think we should have SPX 12. So let's look for that. Yeah, that's 24 months still. 3 month, 12 month, there we go. Here's 12 month. And we'll also update that. Super old. As soon as they change their codes. So this is the MNYDF model. See, it's not updated. We can find it by going here. Isn't data fun? I'm doing SPX, index, fields, vol. Yep. We're looking at 12 month. We can do put, we can do call. I like doing call just because I think it's more consistent. 12 month put, 12 month, say 12 month. There we go. Okay, good. Back here. Doesn't like it. Make a new one. Call this 12 month. Sure. SPX index equals push this code from this name with this variable. Great. So now we go here. Yay, at least it works. Okay, it's updated as of today, and let's compare it to the VIX, right? And the VIX should be a little more volatile than this, right? Makes sense. Because it moves around a bunch, and because the VIX is 1 month of the 12 months that this blue line represents, which is 12 months of volatility as opposed to 12 of these little lines. So let's go back over here. Let's pull these while we can, and then we're going to make it simpler by saying equals this, column equals this. Just a quick visualization hack. Just going to see what is in this data. Do we even have the data? Looks like the 9 month is kind of crappy. The 8 month is also financial crisis, not good. 7 months okay. 6 months okay. 5 months okay. 4, 1. Okay, so now we're going to recast these as business days to try to clean them up a little bit. It just means ignore holidays, basically. And I'm going to add, instead of adding raw, I'm going to say equals this, and that. Get rid of the raw. But give me the. That's right. Okay, and don't forget your dot. There we go. This is just so that when I use this data, I don't have to deal with the fact that the data has gaps. This is to clean the gaps. You see it errors out for one snap. So let's give us a map. Let's give it this stuff. We're going to call this months. This is going to be raw. This is going to be the rows. This is USA equity, SPX, X curve, map 2023 0418 push. And what I'm going to do now is just make this into what's called the map. Over here. I know it's been half an hour, but welcome to volatility. Now you can say mean rows, right? Compare that to, I don't know, the 3 month. And this is the weighted average of all the numbers. That's pretty close to 3 months. Okay, save the file. And what we're going to do is take a, let's go from here, put this here, and put this here, and put this here, and we're going to build the rest of the curve here. And so take this, let's make it 3 months. Should already have this, but who knows. That's 12 months, so put it here. We could say 24, 36, 60. Nope. 4, 3 years, 36 months. Let's call this 5 years, just for ease. I don't even know if it exists, and we know there's going to be a 6 month and a 3 month. And we're going to name them appropriately. This is how we're going to do forward roll. It's a long-winded way of doing it, but I want to make sure that I'm right and not printing to the internet horrible numbers. So go here, and now we're going to look for 3 months. Nope, wrong. 3 months. 3 month call, apply volatility. 6 month call. Let's put, who cares? Call it call. 6. 3. Do we have 24? 24. So here. 24. Yep, they got it. 36. How much do we have here? How about 3 year? No, how about 5 year? Okay, fine. We only have 2 years. Great. So now we know kind of the constraints here. So let's push this data here. This is all dead. And we're just going to say equals push PPG, this. We're going to run this 3 times, and I'll calculate a bunch of forward balls here. Now we got to make sure the math is right. That's what we learned from the French guys. Okay, now we're going to clean it. Remember, we want to clean this. B. Actually, what we can do is a little bit cheeky, but we can pull the logic, and then it's going to show how Rose interprets that, right? Then we add a colon B onto that, and we're going to re-push that. equals push logic. Great. So now let's do this one. And we can literally just use the same formula as above, right? So run the formula of this. Run this. Comma this. Great. And we know that the weight of this is to multiply or divide by 100. How to. Right? That's the same kind of logic we had over here. Divide PVG divided by 100. How to. Right? Take the diff of those two lines. Sub this, sub that. But we need to multiply it by the weights. So how to multiply by 0.5 because it's 6 months out of the year. Sub this, multiply by 0.25, divide by 2.5, 0.25. And now we're going to say square root. Whoa. So let's just make sure the number's right. First of all, it's saying 0.35369, 0.36 equals square root of that 19. Okay, so that's right. It's just I don't know if we have the actual functions to do this. Yeah, we do. How 0.5. Calculus. Okay. Go away. Okay. How 0.5. There we go. And this is going to be USA, equity, SPX, vol, implied, 100%, 3 month forward, PVG equals, copy this. Woo, okay. Now we can do 3 month, 9 month forward. Let's do 3 month, 6 months forward. And we're going to break this into a bunch of forwards. Right? And all we have to do is say, well, look, this is 9 months now, right? And this is 0.75. And let's do the 6 months. And it's 0.5 in the future. Divide by, there's still 0.25 left to wait in the year because it's only 3 months. Pow, 0.5. While we're doing this, let's do the 3 month, 9 month forward. And we're going to go 12 months, multiply by 1, sub 9 months, multiply by 0.75, divide by blah, 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 blah. Oh, that should work. Why didn't it work? Okay, so we'll do it again. Sometimes you need to run it before you actually push it, which is a classic mistake. So do this again. 6 months divided by, multiplied by 5. That should work. Why doesn't it work? It doesn't like this one because, oh, I didn't do that one yet. Aha. Well, Campbell. Come on, Taylor. Okay, SPX, it's probably just the same thing, right? So we'll take this. Nine months. I'm going to call this 9 months equals push, usually 2 rows, this from this with this name. Well, it doesn't like it. Come on, man. I know it exists. Variance swap, give me a break. I'm going to cheat here and use SPY. No, really? 9 months. Oh, I don't want to do bar stops right now. Too much work. Okay, well let's do the 6 month forward then. So we're gonna go here, and we're gonna do 12 months. Multiply by 1. Sub 6 months. 0.5. Divide by 0.5. 0.5. This is gonna be my vol 6 months forward. Which is really annoying because I wanted to do 3-month chunks, but we'll get to that later. I have a hack around that. Okay, now we can do 12 month forward with the same kind of energy here, even though the computer has let us down because they don't have enough. Okay. Okay. So now we're going to do 12 month forward. Okay. Which is the, between a year from now and a year after that. So take this 12 month, take the 24 month, multiply by 2 periods. Subtract the variance from 12 months, multiply by 1. Divide by 1. Boom. Okay, so at least we can visualize these. This one divided by 300. Great. Okay, so let's label this. Say that U.S. equity live volatility source SPX. Okay, how do we want to make this? Let's make this red for the short term, call it 3 months. Then we're going to call this 3 month forward. Then this is going to be 6 months forward. Then this is going to be 12 month forward. And you can put it in like dimensions or whatever. So here, make this one yellow. Is that going to work? How does that look? Looks okay. Say that the 3 month and 3 month forward are a little too close, I would say. Yeah. Oh, it doesn't do it. Let's make it later. That looks worse. Oops. How's that? Sure. So let's give an answer. The VIX curve is actually a curve of forward volatility, aka the June VIX is for 1 month forward vol on the VIX future. On file, give people a little bit of breadcrumbs. Twitterable. Yeah. Whoa, where'd it go? Okay, so that was 50 minutes. I think we can take a break there. The critical thing being variance is additive, and what we can try to do next time, and I'll just post it in the chain, is how to go from these individual curves, which look like, where do they go? Not that stuff, not that stuff. What happened to these? Let's actually just play with it. Put it in the notebook, and then we're done. This will be automated, but first, Rocco needs to know the capacities. Jokes. Okay, so what if this actually pulls? Yeah, let's zoom in. Let's give people a chart on this too, because it's kind of cool. Okay, now we can also take this stuff here, right, and this is going to be SPX. Push this, and I'm going to make a table out of this too, which will be kind of fun. Let's see what it means to make a table in rows. Go, edit. Is anyone watching us right now? It'd be funny if they are. Okay, so me and one other person. Well, I hope that this isn't too boring. Sometimes you gotta get your computer. Okay. So what this is gonna do now is I'm gonna pull this map, aka map of data, and I'm gonna evaluate the column rows. And that's going to give me a new column called rows value. And here I'm going to now make a chart. it's going to be a bar chart. And if I want to learn how to make charts and rows, just go look at the documentation. Best way to do that is just search rows chart. Docs. Let's look at this guy. You can even do that, but I don't want to do it yet. So it's column chart. Column chart. Name English is what goes down here, and then the variable. So we have here is the maturity, the x-axis, and the rows dot value is the y-axis. Boom. So this is the term structure of the VIX, right? And it's going to look a lot like this. CCRV and UXA. Love when it does that. Right, so it kind of has that arc to it. There you go. We could also do a scatter plot. Same kind of energy. Looking down here. Scatter, GDP, and then what do we call it? It's okay, so we're going to call it scatter. Yeah, right. There we go. And we can trim, let's say, limit 9. Ooh, much better. Okay. So it only has 9 months. Limit 9. Great. Rose value we need to change. Let's call this VIX. Futures price. Oh my god, it works. Or we can say, fine, all this. VIX, futures price. Show up because we're still messing around with it. Take a screenshot of this, send it to devs. Formatting. And we're going to post this. New. Think. We'll take this, we'll post it. I can't post a notebook because the data is private. But someday we will. Okay, guys, that's today's mostly stream. In at a tight hour, but you know, now anytime we want to go to rows and mess around with this, right? We know that there is a table of data called USA Equities VIX curve that we can use. So let me give you an example. So let's say you were trying to find what the VIX was in 4 months. You can search for USA VIX map. That's today. Let's filter for month equals 4. And let's get the data. Rows. Columns called rows. Here's our data. Okay, and so now that we have this, we can also update it. It's a lot easier to update. We can rename it. So we're going to say, you know, VIX, 4th nearby, price equals, and now it's going to remember that tree and all the data that came in it. And if I wanted to, I could always double click on it, pull it out, see what else is in there. And then as we kind of grow this analysis over time, you can see that we have the SPX in here. We might have different kinds of maturities. We might have different strikes, puts, calls, that kind of thing. We can deal with all that later, but this was just a first way to kind of, as a reminder, go from something reasonably simple in theory, forward volatility, where variance is additive, into something you can actually use and use in rows to actually harden that logic and have it forever. So thank you guys for watching, and until next